Hello. In this video we're going to explore the relationship between proportions and how we can use them to find certain parts of the circle properties. Now by circle properties I mean that one revolution is equivalent to a rotation of 360 degrees, the circumference c is 2 pi r, and the area is pi r squared. Okay? So we're going to look at the following questions. Suppose you have a circle of radius 6 inches and we rotate through 90 degrees. What is the arc length S associated with the rotation on the circle, the rotation of 90 degrees? What is the area A associated with the rotation of 90 degrees on the circle? Now let me go ahead and draw a picture and see that what we have is a circle and we're saying the radius is r equal to 6 inches. Or I could write this. And what we're going to do, this could be a little bit better horizontal, but we're going to rotate through 90 degrees here, so 90 degrees, and capture this portion of the circle. Now what we can see is that it's 1/4 of the circle, all right? And in part A, we're looking for what's the arc length S, that's this distance right here, arc length. And it's, if we were, even though this curves, if we were to straighten it out and make it a line and then measure it, that's the linear distance we're looking for part A. For part B, we're looking for the area that's inside 1/4 or 1 quadrant of this circle. Okay? Now, so let's take a look at part A. And what I'm going to do is set up the proportion that a partial rotation out of the full rotation is equivalent to a partial arc length to the full arc length, which is the circumference. Now first I'm going to just plug in the 90 degrees for theta. And I'm going to leave this a little bit abstractly because I want to make a point here. I want to solve for S, the arc length. So I need to move the c over to the other side. Since S is being divided by c, I want to multiply both sides of the equation by c. So let's go ahead and do that. Okay, and as you can see, c is cancels out here, and you're left with arc length is 90 over 360 times c, the full circumference, but 90 over 360 is really 1/4. So what we're saying here then is the arc length that I'm looking for is 1/4 of the total circumference, or the total arc length. And we can see that visually here. Okay? From here, if you want, you can of course just put in c equals 2 pi r. So 2 times pi times 6 inches. Okay? And I'm going to use 3.14. You can use the much more precise pi that is in your calculator. And when I do all this, I'm going to get 9.42 inches. Okay. So in this case I would say 2 times pi times 6 divided by 4. Okay, so that's our first way of solving it. Well, there are many ways of solving this. I'm going to go through a couple and then move on to the second part. So let's say another way of looking at this is to say I'm going to plug everything in that I know. And you could even put 3.14 in here. Now I'm solving for S. S is being divided by 2, divided by pi, divided by 6 inches. So I'm going to multiply both sides by that. So I'm at 90 over 360. And I'm going to multiply by 2, by pi, and by 6 inches. And I'm going to do the same thing to both sides. And of course, these cancel out, these cancel out, these cancel out. I did that purposely so I could isolate S. So now S is 90 over 360 times 2 times pi times 6 inches. And if you put this in your calculator, you would say 90 times 2 times pi times 6 divided by 360. And you would get, let's see here, 9.42 inches. Okay? So that's another way of doing it. And finally, the last way we could do this, well, not the last way, there's really probably so many ways you could do this, I shouldn't say that. Last way I'm going to do it. All right, I put in 90 over 360, and then S over 2 times pi times 6 inches. All right. And here I already go ahead and put this in my calculator and get 0.25, and S is being divided by 37.68 inches here. And now to solve for S, I multiply both sides by 37.68. And finally, notice what you have here, 1/4 of the total circumference. The only difference, this is in decimal format. That's it. So, of course, you're going to get the same answer either way. Now we're going to go ahead and look at the second question. What's the area associated with this rotation? So that's the space in here. And of course, we measure this with little squares. Essentially, we're saying how many squares can fit in this space, where each square is 1 inch by 1 inch. A very known quantity, so something we're familiar with, and we can say, oh, I know how many square inches fit in here. And of course, when we're talking about the total area, it's how many square inches fit in all of this area, all of this space. Okay, so let's take a look. So in this case, I would set up the proportion. The partial rotation is to the full rotation, as the partial area is to the total area. Okay. Now I'm going to go ahead and fill all. Oops, this was supposed to be 90. Go ahead and fill this in. And of course, when you square this, it's going to be 6 times 6 and inch times inch. So you're going to have square inches here. All right. And I'm going to go ahead and make this a number. So I'll have 0.25 here, because that's 1/4 of 0.25. This A over 113.04 square inches. And then just multiply 0.25 times 113.04. And you should get 28.26 square inches. All right. Thanks so much for listening.